Sports science, neuromuscular system. Your brain is the main reason why you can move. If you want to move a body part, an impulse will be sent from the brain in the central nervous system down towards the muscle to cause contraction. This is an action potential which will travel down the spinal cord and reaches a motor neuron. On this motor neuron, saltatory conduction will take place. The stimulus would have to jump over the myelinated sheath of the motor neuron. This is because the myelin sheath is made of cells where depolarization would not occur. Depolarization is a change within a cell. It then goes along an axon at a faster rate, which means the muscle will move faster as the impulse is quicker. After saltatory conduction, the impulse will reach the neuromuscular junction. There is a gap between the motor neuron and the muscle. In order for the impulse to travel through this neuromuscular junction, it will have to release chemicals called neurotransmitters. An example is an acetylcholine. This will travel down a vesicle until it will reach a presynaptic membrane. This will travel through the gap and go towards the postsynaptic membrane, where when it has reached this postsynaptic membrane, there will be the starting filament theory in the sarcomere in the muscle where it will contract. A motor unit is made of many motor neurons. When doing exercise, motor units vary depending on the duration and intensity of an exercise. This is so the motor units will provide a different type of contraction. There are three types of motor units: the slow oxidative, the fast oxidative glycolytic, and the fast glycolytic motor units. There needs to be tension in the muscles, therefore these motor units need to recruit more units in order to create that tension and power. Slow oxidative motor units will be recruited if the muscles are not working that hard and can last a long time, so like a marathon, as these fatigue the slowest due to them having high amounts of mitochondria. The fast oxidative glycolytic motor units will be for runs like 800 meters, and fast glycolytic motor units will be recruited for runs like a sprint. The faster the motor unit, the faster the tension is built. However, the slow oxidative motor units will cause the tension to last longer than the fast glycolytic ones. If there are multiple action potentials, then the tension will keep rising until it plateaus, but then you can still see the effects of the action potential on the tension. The number of motor units is recruited is dependent on how large the resistance is. The higher the resistance, the more motor units there are needed, as the muscles need to overcome the force that the muscle is fighting. Typically, smaller muscles require few motor units, whereas large muscles, such as the quadricep, need loads. The size of the motor units are determined by the number of muscle cells inside them. So if a motor unit has more, then they would exert a larger force. Slow oxidative motor units are the first called up, and then the fast oxidative glycolytic, and then the fast glycolytic. As fast glycolytic have the highest force, and the slow oxidative have the least force. So if a high force is needed, and there are only slow oxidative motor units, then the fast oxidative glycolytics will be called up. But if that's not enough, then the fast glycolytic units will be called up to try and get the most power possible. In order to prevent tear and too much tension, the body has muscle spindles apparatus and Golgi tendon organs. Firstly, the muscle spindle apparatus are in the belly of the skeletal muscles, as they detect the stretch and velocity of the muscle. This is because they have extrafusal fibers which have actinomyosin. This means that a contraction can occur. There are also intrafusal fibers in between these extrafusal fibers, as these are the main part that detect the stretch. This would then send an impulse to the brain, also going through the spine. After the brain has received this information, it will send back an impulse through an alpha motor neuron through the neuromuscular junction and into the muscle causing a contraction. When doing a weight lift, an eccentric exercise can cause the muscle to stretch, therefore this contraction will shorten the muscle so it doesn't tear. There is a test for this, and it's called the stretch reflex in your muscle, where it can be tested on your leg by lightly hitting your knee tendon with a small hammer. When this happens, your quadricep and hamstring will stretch and the impulse will be sent to the brain, and the brain responds, causing the muscle to contract at the quadricep and hamstring, causing the knee to jerk a bit. Then the muscle spindles is also involved with the stretch-shorten cycle. This cycle uses eccentric contraction and the muscles are pressed. The cycle is where someone jumps higher than they normally can, as the force exerted is a lot larger due to the pressed muscle. There is also another exercise which uses maximum force in your muscles, the plyometrics exercise. This exercise is quick, fast jumping up and down where the muscle will be stretched quickly, which will result in the muscles contracting quicker, as well as there being more force will be exerted as the muscle spindle will stretch. The tendon connects the bone to the muscle, and inside this tendon is the Golgi tendon organs. These detect tension in the tendons. When there is too much tendon, a nerve will be sent to the brain and the alpha motor neuron will send an impulse to the muscles and the muscle will relax. This would decrease tension. However, this is the inverse of the stretch reflex, because as the tension is so high when perhaps holding a weight, it needs to decrease. Therefore, when the impulse gets sent from the brain to the muscle will stretch as it will relax, and the force of the weight will pull the arm down, stretching that bicep muscle. In our class, some students did a Wingate test where they would pedal as fast as they can for 20 seconds on a static bike. The results are hard to see, I know. In this, we were able to measure their peak power and their whole power throughout the exercise. In the first 5 seconds, the student would be at his peak power, and at 4 seconds was his highest power at 682 watts. At these 5 seconds, the power will begin to slow down as the student will be using fast glycolytic motor units, as he is using as much power as he can, as the fast glycolytic motor units are the strongest. However, these fatigues showing why the student's power is decreasing. Throughout the whole test, the student is working as hard as possible, meaning near the end, the movement will become more droopy and less controllable as the muscles have worked to its maximum and the fast glycolytic motor units are fatigued. At the beginning, the slow oxidative motor units will be introduced, then the fast oxidative glycolytic motor units will be introduced, then the fast glycolytic ones, as more motor units are needed to be recruited at this level of power. When pedalling, it is like the muscles are stretching, meaning those muscle spindles are doing their job in contracting the muscles to shorten them to prevent a serious injury. As a result, the end of the test is the student's lowest power at around 5 watts per kilogram, showing that the student has fatigued hugely and will be out of breath. In sport, the neuromuscular system is crucial for the movements and power when you are playing, especially in football, as football lasts around 90 minutes and you will most likely be jogging the whole time, at least jogging. Which means that the contractions in your muscles won't be very strong in these situations, therefore the slow oxidative motor units will be recruited in order for the muscle to contract with that power. Slow oxidative motor units also fatigue the longest, so they will hopefully last a full 90 minutes depending on how fit the footballer is. Different motor units will be used for different scenarios of the game. So for example, when wanted to shoot the ball at a large amount of power, all 3 motor units will be used to create that power, with the most important being the fast glycolytic motor units, as these have the most muscle cells which produce the most power. This means that all the motor units will be working together. They fatigue very quickly, but as a scenario such as shooting such a period of time, then the fatigue side of it is pointless. This is why footballers do not work at maximal exercises, as these fast glycolytic motor units will not last anywhere near the 90 minutes, as it will only last around 20 to 35 seconds. When perhaps a goalkeeper is reaching out to save a shot, their bicep will be stretching and the muscle spindles will detect this, causing impulses to be sent to the muscles to contract so the muscles don't overstretch and tear.